Okay, quadrilaterals. This is the last thing that we need to cover before our Unit 2 test. Hope you're listening. Your Unit 2, y'all listening? Everybody listening? Y'all with me? She's just scanning out. That's all she's doing. Listen to me. Listen to the words that are coming out of my mouth. Ready? Your Unit 2 test is this week. Okay? It is the stuff in your notebook that is after your Unit 2 table of contents, including the stuff we're covering today and tomorrow. Okay? It's probably going to be Thursday. If it's not Thursday, it's Friday, for sure. Y'all with me? 25 questions. It's going to cover the stuff from that last quiz, which I will refresh y'all on the day before, and then the stuff we're doing right now. You have to be signed into your Google account. Okay, yeah, it's a lot faster. All right. The last thing we need to cover in Unit 2 is quadrilaterals. The good news is you should know these. The stuff that you're going to have to think about will be parallelograms and rhombuses, because you should know what a rectangle is, right? You should know what a square is, right? First, before we move to that, the word quadrilateral. What does it mean? It means four-sided polygon. Do y'all remember the word polygon? Polygon means a 2D shape. Whose phone is this? Solid? Okay. Can I put it?
Put it upside down.
Okay, that's what I. All right.
Do I should read this?
As on a single platform.
Okay, first of all, I don't like camera. Oh, that was Google Classroom 1. Bless your heart. Look. 6 watt. Classroom. That was nice. Right there. All pass. There you go. Don't judge her by that. All right. Four-sided polygon. Quad is the prefix for four. Lateral, especially if you know football, that is side. Four sides, right? Or technically behind you. But anyways, please open your little Flipbook to where it says Parallelograms. Try your best to fold it to where it's flat, because we're going to write on it. All right. Before we look at some example problems, let's look at the properties. Parallelograms have a lot of properties with them. Opposite sides are, hence the name, parallel. Opposite sides are parallel. That's why it's called a parallelogram. Imagine that. You with me? Did you write it down? Opposite sides are also congruent. So let's make some marks on our picture. You need to know what the notation is for parallel when you have a picture in front of you. You already know what the notation is for congruent. That's when the little tick mark matches, right? That means congruent. And then if this is congruent to this, I have to put a different number of tick marks because it's a different side, correct? It's not the same. You with me? You good? Okay. Parallel. The notation to let you know that opposite sides are parallel, if I give you a picture and I tell you it's a parallelogram, then you know immediately that opposite sides are parallel. If I give you a picture and I don't tell you what shape it is, but you see these little triangles like that, that means that those sides are parallel. There's a second type of notation. It's not a triangle. It's an arrow. You'll see arrows, and I tend to do the arrows because they require less writing. The arrows also mean parallel. Okay? So the little triangles mean parallel. Write this down. And the arrows mean parallel. You need to know both. So up here, in this picture, opposite sides are parallel. So this is going to get really crowded. I'm going to do the little triangle on the shorter side, and I'm going to do the arrows here. So we've got opposite sides congruent, opposite sides parallel. I want you to think of it as a rectangle that has been, what? Shifted, like tipped, slanted, pushed. Can't think of anything else. But imagine you have a rectangle and it's just been pushed so it's slanted. That's a parallelogram. All right, now let's talk about the angles. This is the stuff where most people tend to forget things. Opposite angles are congruent. Opposite angles are congruent. So if this is 60 degrees here, then opposite measures what? 60 degrees. Don't write that. I'm just making an example. That's why I wrote over it. If this is 110 degrees, then this would be what? 110 degrees. Okay? Consecutive angles. See this? Consecutive angles are supplementary. Let me explain to you what consecutive means. Opposite means what you already know. Like if you draw the diagonals, the opposite angles are the ones on the ends of the diagonals, right? You already know that. Okay, consecutive means side by side. If you were to trace the shape, two consecutive angles are when you come, like if you trace the shape, they're side by side. So those are consecutive. Got to do a lot of erasing. Those are consecutive. You see that? These are consecutive. Are y'all watching? I've lost half of y'all. Y'all are just ticked off that you have to learn. I'm sorry. Those are consecutive. Yes? And that's it. I think I already did those two. But those are consecutive as well. Consecutive means same side. So like if you trace one side of the shape, the angles that are on those ends are considered consecutive angles. Okay, the relationship is that consecutive angles are what? What does supplementary mean? They add up to equal 180, which makes perfect sense. Look at the picture. What type of angle is this? It starts with an A. This is acute. Let's go consecutive. I'm going to go up. What type of angle is that? Obtuse. We said last week an acute angle is never equal to an obtuse angle, which is your clue that maybe they add up to 180, and they do. Imagine, if you will, your parallel lines, you'll see where I'm going with this, cut by a transversal. Those angles are called consecutive interior. Remember that from your cheat sheet? That's why they're supplementary. Same thing if you went this way. Same thing if you went that way. Ooh, my hand. That way. Same thing if you went that way. And that looks really bad now. Let me take that off. There we go. All right. Diagonals bisect each other. You may have to write a little reminder. What does bisect mean? If a segment has been bisected, it's been cut how? In half. Cut in half. Now, looking at this picture, it's kind of hard for us to put the angles. These are the angle relationships, we can't really draw those in that picture. If you have any room anywhere on your notes, maybe in the same box as this one, or if your paper folded up high enough that you have a little bit of a gap right there where the staple is, I would like you to try to draw a little parallelogram, and just to show that the congruent angles are opposite, and that we're going to name A and B. Say that angle A plus angle B equals 180. Wherever you can find room to put that, it would really help you. There's one more thing that I think would help, and this might be something that you have to write above the next box, like where there's these examples, there's some room right here. You see that? I want you to write, look for alt int angles. Do you remember what that is abbreviated for? Wherever you can find room. Look for alternate interior angles. Alright, now let me show you why. Let's go through this first practice problem. If you look at the picture, there's a lot of information in it, right? I need you to pay attention. This is where, when people get sloppy with their math work, it really aggravates me. Because they'll be like, I don't get it. And then I'll see their paper and they have something like this written down. And they'll say, I've tried it and I don't understand it. I keep getting it wrong. What aggravates me is they're not even paying attention. What is this? What's that from? Because it has this, it's from a what? Thank you. I'm going to ask it again, and if y'all all will answer, that'd be great. What does this little symbol mean? It means degree, which means that it came from an angle. And what is this? It's not an angle, it's side AB. Do you see that? It's just two letters. That means AB. That means what? Angle. So what I'm saying to you is, if you're throwing answers with degree symbols when it's asking for sides, and then you're throwing answers with linear measurement when it's asking for angles, then I can't help you because you're not even paying attention. You got me? So make sure you're paying attention. Is it a side or is it an angle? There's your first, okay, so my answer needs to be degrees or my answer needs to be a linear measurement. Now let's try to actually answer it. So what would be nice, you probably, on your paper, maybe even make a note. These are sides. Those are referring to sides. So they need to be the linear measurement that you see in the picture. And these are referring to angles. So they need to be degree measures, right?
Let me see.
Maybe I shouldn't have put her on the couch. Don't be so bossy. All right. Let's look at the picture and see if we can come up with the links or the measurements. Side AB is here. Do we know it? What is it?
8.4.
Why? Because it's directly opposite, and opposite sides are congruent. They're also parallel, but what helps me here is that they're congruent. So this is 8.4. Remember, opposite sides are congruent. All right, what about AC? Well, find it. A to C is here. Now, is that a side? No, it's starts with a D. It's a diagonal, right? Do we know the whole thing? No. Do we know a portion of it? Yes. What do you know about diagonals of a parallelogram? They bisect. So if this is 10, then that's 10, which means the whole thing is
20.
all right. What about BE?
7.
BE is here, but it's just that portion, right? Look at the other end of it. Now, did you say 33? Be careful. 33 is an angle, and these are all sides. BE is right here. It's a diagonal. Do you know the other end of it? You do. So it's 7, right? All right, now let's find these angle measures. Now this is where, if I had to say what's the hardest part about parallelograms, it's the angles. And that's because of the diagonals. When they get drawn, you now have alternate interior angles. And it makes it hard for people to be able to see them because you don't see the parallel lines. So what I want you to do, I'm going to take my paper and I'm going to get rid of all of the extra writing. Now, you can't do this on your paper, but you can look up here at mine. I'm going to get rid of all of the linear measurements because I want your mind to mute all of the extra stuff. Now, if you're looking at it, what do you notice? There's only angle measures. Do you see that? Okay. Is that right?
We're gonna do ice cream on Mondays instead of Fridays because on Fridays we do ice cream at school only.
Okay. So did you get an ice cream today? Oh, is he taking you to get one right now? No. Okay. Thanks, Papa. So funny.
Ice cream on Mondays.
Ice cream on Mondays. He used to call it Frosty Fridays, but he gets ice cream at school on Fridays. So he's getting a double that. Now that makes sense. It's been like, Friday night. You don't need to see that again. All right, focus on this. Here we go. Let's find the angles. We've got to find the bad angle first. I've lost y'all.
I'm waiting
Squirrel.
on
Funny. I'm sorry. Squirrel.
There he is.
There he is, the man of the hour. You can set that on my desk. I don't know why I asked for it. Okay. The pillow cannot go on the floor. Just heads up. I know. All right. Let's find the bad angle. No. Okay. The bad angle.
Oh, I get it.
Yeah, y'all with me now? Oh, some of y'all are still so mad that you're having to learn.
I'm pretty happy.
I'm just tired.
I know.
And cheer.
The bad angle is right there. BAD. Do I know it right off the top of my head? No. I know part of it's 23. Don't you dare say, oh, the other part's 23,
No.
so it's 46. It doesn't work that way. Look, here's what I need you. Here's what I need your mind to see. Y'all ready? I need you to see parallel lines. Here is one transversal. Here's a transversal right there. You with me?
I see it.
Yes.
I see it.
It is alternate. Look right here. You see how this is touching the black and the green? And those are your parallel lines. There's your transversal. So this is 43 because of alternate interior angles. Now here's the beautiful thing. If you can see it in one example of a parallelogram, it's the same thing every time. It's the same concept every time, okay? because every parallelogram has the same properties. You just have to be able to see the alternate interior angles. Okay, so let me back these lines up so we can label. So this has to be 43. So that means now I know enough to say the angle is 66. Now we've got to find angle A, D, C. A to D to C. Okay, so that's here, right? And I know nothing about this one. But I know that,
Wait.
what?
Like every side.
Consecutive angles are supplementary. We just said from here to here is 66. So then over here, because they're on the same side of the parallelogram, they have to add up to 180. So 180 minus 66 is 114. Now we've got to find angle A, B, D. Okay, so that's here, right? Okay. You just, multiple ways to do this. You just said consecutive angles do what? They add up to 180. And you just said that this angle down here is 114. If this is 114, this is opposite, then what's this angle? 114. And what's this portion of it? This portion right here. This portion's 33, which means I can take that off of 114 and I would have the angle that they're asking for, which is what? 81. Yep, nope, okay. I'll do it, sorry. That was like 4 steps, so I'll do it again. You ready? This is the angle we need, right? Yes? Okay. Notice it's a portion of this whole angle. Yes? Okay. That whole angle from here to here, try not to make my marks too big, is 114. How do I know that? Because the other one over here we said is 114. They're congruent. Opposite angles are congruent. If the whole thing is 114 and this little chunk is 33, subtract it off of 114 and then that gives you, what did you say, 81? And that gives you the 81 that goes right there. My only complaint with parallelograms is writing in all of the information. It gets very crowded and confusing.
The whole paper is so messy.
All right, now that was applying sides and angle measures. Now let's level it up to high school level to where we have polynomial expressions. Don't panic. It's exactly like the same concept as the parallel lines, transversals, and algebra worksheet. Y'all remember that? That y'all were working on diligently at the end of last week, and y'all turned it in. It was great.
No.
Oh, you did. You turned it in. It was page 24.
No.
Anyways. Yeah, y'all remember.
Okay.
This page.
Oh yeah.
Remember that?
I haven't turned on.
I have it. It's a 0. Oh.
I have it. Wait, was it like your story?
Oh, not really.
Oh.
It was, you
Had a
could
partner
work
in it,
with
so-
a friend if you want, but it was an individual. Is your name on it? Okay. Remember this sheet where y'all had the special angles and you had to find the relationship and then you set up the equation? Remember that? Okay. This, right. You just have to put Andy. You don't have to put his last name. This is the same thing It's the angle measures, instead of them being plain old numbers, they're polynomial expressions. So you have to look at the properties and ask yourself, what's the relationship? Guys, it's the same thing every time. They're either equal, or add to 180, or if it's a diagonal, it's been cut in half. So those are the relationships every time. You have to look at the picture and ask yourself, what am I given? I'm given what? Is it an angle or a length? In this picture, what am I given? Angles or lengths? It's angles. How do you know? The degree symbols, right? I'm trying to help you understand, like that's how simple it is. Okay, now you have to ask yourself, are they opposite angles or consecutive? They're consecutive. What do you know about consecutive angles? There's your relationship. There's your equation. So set it up. Since they are consecutive, I don't know if you want to label this. They are consecutive angles, which means they add to equal 180. So we're going to write 7x minus 13 added to 4x minus 5 has to equal 180. Now you solve that and then look up here and see if you got it right. It is a nice, pretty number. Did you get it? You should get x equals 18. Now, did it ask for x? No. Hold up. Wait a minute. Look at the picture. What does it ask for? Okay, angle P to S to R is here. What expression in that picture is going to equal PSR? If you forget the property, opposite angles are congruent, look at the picture. This is, careful, that's acute. You see how it's less than 90? There you go. This is less than 90, but this one is more than 90, so it's not that one, it's the opposite one. So you're going to plug 18 into, let me relabel my picture. This is going to be 7x minus 13 degrees. And that's what you're going to plug it into. Huh? Did you get 11x minus 18 equals 180? Negative 13 minus 5. Right there. Negative 13 minus 5. It's negative 18.
Wait, what are you solving?
You're finding the measure of angle PSR.
What are you laughing at? I just found all the angles.
Oh, well, you overdid it.
Well, I mean, all you did was plug it in.
Right, but you only have to plug it into 7x minus 13. Did you get 113
Yeah.
degrees, y'all?
That. Sorry.
Yes, you
We
do. No, I do want to. Now go to your practice paper that I already gave you. It is page 28. I am not expecting you to copy the properties at the top, although you can if you want to, because then you don't have to use your yellow flipbook. But I am looking for you to answer these questions. Yes, you should be able to breeze through the first, let me tell you, the first 6 questions, the first 6 are just numbers, no polynomial expressions. The back is when you start getting the polynomial expressions. No, put that on my desk, because that's all for my notebook.
No, I
Yeah.
just put this up there.
Oh, I gave you an extra? I'm sorry. You have 14 practice problems. 6 of them are just numbers. Yeah. No, that's the properties. That's what I was saying. You don't have to copy them. You're going straight to the practice problems. Hey, come on, y'all, level up. Hey, it's high school. Look, if this is 68 here, this is 68. Then what else is 68? What angle? Name the letter. B. B. Over here. This is 68. If this is 15, this side, then what else is 15? DC. Y'all, this is not rocket science. The hard stuff should be when you get to the back where you have to set up the equation. If this is 8, what's this over here? 8. Now I've got to get my calculator to figure out the other angles. They add up to 180.
Okay.
The whole box does add up to 360. If you did divide it, you have to divide it by 2. It would be faster to just do 180 minus 68. And that's it, like 180 minus 68. Right, he was saying it's a quadrilateral. Y'all remember that all 4 angles in a quadrilateral add to 360, so there is another technique there. But it is faster to just say 180 minus 68, and that's where you get 112 here, and that's 112 there. Does that make sense? So now it's a piece of cake to fill it in. AD would be 8, DC is 15, angle A is 112, angle B is 68, angle C is 112. Look at that, y'all already have one done. If you think you've got this under control and you're more worried about when it comes to the equations, then I would encourage you to move on to number 7. Save the easy ones for flex tomorrow. Move to 7, because that's where you get polynomial expressions. That's where you have to ask yourself, what's the equation? Are they equal? Do they add to 180? Or is something cut in half? So if we look at 7, yes, that's the equation. Set it up, they equal. Now do pay attention to what it tells you to solve for. This does say solve for x, so you're done at x. Number 8 does not say solve for x, so you do have to go a step further and plug it in, okay? Y'all try 7, please. Jump to 7 and try it. Yes. You look at the picture and you see what's labeled. Is it an angle or a side or diagonal? After you see what's labeled, then you think of the properties. You know, the angles that are congruent, or the angles that add to 180, or the sides that are equal. In this case, what is it? What's in 7? Those are sides. And they are opposite, which means they are, I already said it, they're what? They're equal. So they're equal. That's your equation. Set them equal and solve. Do not look up here and just copy this down. Make sure you understand where this came from. Did you get 8? Is it 8? I can't remember. gonna write my answer right here in the corner. I think you're fine with number 8. Remember that they're all easy if you'll give it a chance. Like, no, I was just saying that when you get to the back is when people panic. People panic because it doesn't have the plain old numbers. They forget they just have to set an equation. Somehow. There's a relationship somehow. Which one? Oh, well, you just have to set that equal to that. Oh, no, wait, they're saying RT. Where's the T? Okay, if the whole thing's 30 and the diagonals bisect, then it's been cut in half. Means what's half of 30? 15. So from here to here is 15. From here to here is 15. What's it ask? What's that letter? Then that's, yeah. Now hold on.
So this one's 15.
Right.
Is 30.
Right. Now if that's 7, then what's that?
Still equal 30.
No, this is a different diagonal. We jumped. There was this one. That was 15 and 15. Now you're on this one. This is 7. 30. It's okay. Yeah. So it's not that the diagonals are equal, because that's impossible. This is clearly longer than this one. It's that the diagonals are cut in half. So if that's 7, then that's 7. Which number? 4? Let me look at my answer keys.
Yes, that is right. You did it. Remember, I subtracted by 9. No.
Yeah, I know that. So like here to this side and then Q on this side.
Hey guys, on the back, look right here. This picture is a little misleading. In number 11, this angle is clearly in this corner, and then this angle is up in this corner. Are those equal or supplementary? Trust your gut, y'all. Look at the properties. Are they opposite or on the same side? They're opposite, so they're equal. Those are equal. This picture looks a little tricky. This 8x minus 12 is in here,
Yes.
and then this is in this corner. Are they equal? No, they're not. They're what? Supplementary. It's hard for me to draw but I try to draw with 2 different marks. Those are supplementary because they're on the same side of the parallelogram. So I got a decimal. Add it, send it back up. I think you get 32 divided by 8. It should be 4. Alright, so I would. Alright, go ahead. You're good.
I just think you think
No.
It's 32. Now subtract. See, there it is. Subtract that. You're going to get negative 8 equals. Negative 8x equals negative 32. And now divide.
I'm looking for number 8.
Wait.
I got it.
Do you mind? You're good. Go on. No, you're good. Go on. Come on. You're fine. I don't want you any more mad than you are. All right.
Oh wait, no, never mind.
Oh, okay.
Never mind.
I'm just
Let me go ahead and stop this. Number 13. Anytime the diagonals have been drawn and there's angle measures in your picture, that's an indication that alternate interior angles is going to come up. Let's look at this problem. KLH is 134. K to L to H. So they're saying this whole thing whenever I need to draw like the whole angle and a diagonal is drawn, I draw it to go outside of the shape to remind me I'm talking about the whole thing. I'm talking about from this side to this side is 134 degrees, right? It says solve for x. Well, look where x is. X is up here, and it's in this angle here. Yes? Okay. So we got to ask yourself, what are our clues? What do we know? We know this big angle is 134. We know the consecutive one to it has a portion that's 4x plus 9. Somehow the 25 is going to play a role. Find your alternate interior angles. You got parallel lines. You've got a transversal right there. That 25 is going to copy to right there. Do you see that? And then now, I know this is 25, which means I have my equation. Two ways to do this. You can set up the long equation where you know that this crap plus this mess has to equal 180. That works. Or think to yourself, I know what it has to add up to, 180. I know this is 134. Subtract that off. 180 minus 134 leaves me with, so I know this has to be 46. I know a portion of it is 25. Subtract that off of 46. What do you get? 21. No, it's not the answer. That's how many degrees are right there. That's how many degrees are in that expression. So you could have gone, this is route 1. Route 1 would have been 134 plus 25 plus 4x plus 9 has to equal 180. But look how messy that is. Route 2 is what I call the subtraction route, where you say to yourself, I know they add up to 180. I'm going to take 134 off. Then I'm going to take 25 off. Then I know that 4x plus 9 has to equal 21. I think you do get a decimal in this one. Right. Hold on 1 second. Let me check my answer key. Okay. Can we get decimals
So wait,
for
can
any
I
answer?
write 42 second option? Start from here. Or do I have to do that?
No, I don't know. Plus. No, I didn't. Did y'all subtract right?
I don't know.
Hold on, what's that? 180 minus 134, 46 minus 25, it's 21. Okay. Oh, when you subtract, that's what it is. Subtract 9. 21 minus 9 is what? 12. And that's why x is 3.